The highest rated Cyber Green primer pair is displayed. For your specific experimental conditions, you may want to consider alternate pairs which also meet all search criteria. The program also supports Cyber Green primer design for allele discrimination assays. When you download a sequence from NTRES containing SNP information, the program automatically loads and displays it in the SNP Information tab. It selects the first SNP by default. Use the Select SNP or Unselect SNP buttons to design the desired assay. The assay will contain both wild and mutant versions of the primer that spans the SNP. If the SNP information you need is not in the GenBank file, you can easily add it. Select the sequence, go to the Tools menu and click SNP, Add. Type the mutant base, the SNP position, and click Add SNP. The added SNP is displayed in the table. If you have a large amount of unpublished SNP information, you can load it by converting it into a GenBank-like format. We provide a template for creating such a file in the Load SNP section of the online help. Copy and paste the template in the Notepad editor. The locus and accession numbers are generally the same, but you can specify any value for locus. Number of BP is the number of sequence bases. The sequence type must always be SNP. Add all the SNP locations as variation features in the required format, then paste in the sequence. It must start with a new line and end with a double slash. To view alternate Cyber Green primers, click All Primers button. The primers are displayed in the order of their rating. You can select any other primer pair with a click, then click the Replace button. You can also evaluate pre-existing Cyber Green primers. For example, to evaluate a pre-existing primer pair, select the sequence from the Sequence Information table. Go to the Analyze menu and select Evaluate Primers or click the button. Type or paste the primer sequences in the text fields, making sure they are in the 5' to 3' direction. The primers will be evaluated with their default parameters. The results are displayed in the Primer Properties tab. Click the All Structures button to see a graphical depiction of the secondary structures. You can blast search the primer pair or amplicon against the relevant database to verify specificity. From the Analyze menu, select Blast Search, Primer Pair, Amplicon, or right-click on the primer and select Blast Search Amplicon or Primer Pair. Your Cyber Green primers may also be used to design molecular beacon, TACMAN, and FRET hybridization probes. Just check the option Use Primers Designed in the Cyber Green mode in the corresponding probe search parameter window. The program will select the best Cyber Green primer pair for the hybridization assay, including the alternate primers designed in the Cyber Green mode. For example, to use Cyber Green primers to design a TACMAN assay, switch to the TACMAN design mode and select the sequence from the Sequence Information table. Go to the Analyze menu and select TACMAN Search or click the button. Check the Use Primers Designed in the Cyber Green mode option in the TACMAN Search window and press Search. The results are displayed in the TACMAN Properties tab. To export the results, go to the File menu and select Export Cyber Green Primer Results. Then select the data to be exported. The results are saved in a .csv file format and your spreadsheet program is automatically launched. You are now ready for ordering oligonucleotide synthesis or importing the data into a central database such as Oracle. This capability is available in all modes. You can create an attractively formatted report of any assay for your lab notebook. Go to the File menu and select Report Preferences. Choose the data you wish to include in the report. The Advanced button leads to a panel for your name and comments. To print or save the report, press Print Preview and select the desired function on the toolbar. Saved reports can be viewed by going to File, Open Report. To design TACMAN probes for selected sequences, switch to the TACMAN mode. You can design both standard and MGB assays for SNP genotyping or differential gene expression. You can also design oligo sets for multiplex reactions of up to 4 sequences. Select the sequences from the Sequence Information table. From the Analyze menu, select TACMAN Search, then Standard or MGB, or click the button. You can specify the primer length, TACMAN probe length and melting temperatures, or you can accept the default values we provide according to TACMAN design guidelines. We have carefully chosen the default design parameters based on empirical evidence and expert opinion. Optimal primers are designed as close as possible to the TACMAN probes without overlapping. By default, options are selected to design primers which avoid template secondary structures and cross-homologies. TACMAN probes and primers are also checked for secondary structures and cross-hybridization. The Advanced Search parameter and Advanced Primer Pair parameter windows allow you to set limits similar to those in the CyberGreen design. By default, the program rejects standard TACMAN probes with more G than C bases. Allele ID rejects all MGB probes with a G at the 5' end because there is strong empirical evidence that such probes produce less fluorescence. For designing single-tube multiplex TACMAN assays, select up to 4 sequences and launch TACMAN Search. The multiplex option is chosen by default. It causes the program to check the TACMAN probes for cross-dimers with each other and with all the primers in the pool. If the multiplex option is not chosen, each TACMAN probe is checked for cross-dimers only with its amplifying primer pair. The highest-rated TACMAN probe and primer pair is displayed for the selected sequence. For your specific experimental conditions, you may want to consider alternate pairs which also meet all search criteria. Start the search by clicking the Search button. The search quality is displayed in the Search Status tab. Detailed search results are displayed in the TACMAN Properties tab. Graphical views of the primer secondary structures are available by right-clicking in the Primer Properties table. Likewise, the TACMAN secondary structures are available by right-clicking in the TACMAN Properties table. TACMAN probes can also be designed for allele discrimination assays. If the sequence has a SNP selected, both wild and mutant probes are designed for it. To view alternate TACMAN probes, click the All TACMAN button. They are displayed in the order of their rating. Select any TACMAN probe, and the best primer pair associated with it will also be selected, but you may select any other primer pair. Click the Replace button. The selected TACMAN probe and primers will replace the current primer probe set. You can use pre-existing TACMAN probes or primer pairs and ask the program to complete the assay, or simply evaluate the oligos if you have a complete set. If you enter an existing primer pair, the program will evaluate it and design the best compatible probe for it. You can use this feature to adapt a successful CyberGreen reaction into a TACMAN assay. If you have a TACMAN probe, the program will design an optimum primer pair. Thus, you can use pre-existing TACMAN probes or primers as a base for finding the primers and probes on other targets for multiplexing. Select the sequence from the Sequence Information table. Go to the Analyze menu and select Pre-designed TACMAN, or click the button. Type or paste the primer sequences in the text fields, making sure they are in the 5' to 3' direction. If necessary, change the TACMAN search parameters to meet experimental requirements. The results are displayed in the TACMAN Properties tab. Right-click on any line to see a graphical depiction of the secondary structures. Allele ID helps you design an optimum set of primers and probes for single-tube multiplex TACMAN assays having up to 4 sequences. Select the sequences for the multiplex reaction by clicking their names while pressing the Control or Shift key for Windows or the Apple or Shift key for Mac. Then select Standard or MGB Search. Specify a name for your multiplex set and the number of alternate sets you want to design. You can even ask Allele ID to design primer and probe sets that will be compatible with pre-designed sets from publications or your prior work. Select the sequence, go to Evaluate TACMAN. Enter just the TACMAN probe, primers, or both. Indicate the templates with pre-designed oligos as reference genes. If a pre-designed oligo is for SNP discrimination, choose whether you want to use the wild or mutant probe in the multiplex assay. Launch the search. The only caveat is that search parameters you choose must be compatible with the pre-designed oligos you have entered. Needless to say, this may be most useful for incorporating a well-proven reference or housekeeping gene in your reaction. The search results are displayed in the Multiplex Properties tab. An overview of the results is available in the Multiplex Set tab. For clarity, to see how Allele ID chooses the most optimum multiplex set, let us call a set of 2 primers and a probe an assay, and a group of assays, 1 assay for each sequence, a multiplex set. Allele ID first designs the best 50 or so primers and probe assays for each sequence. Then the TACMAN probe in each assay is checked for cross-dimerization with the primers and probes of all the assays of the other sequences in the reaction. Assays that exceed the cross-dimer limits are rejected. Potential multiplex sets are created by grouping 1 successful assay for each sequence in all possible combinations. Each multiplex set is then rated according to the formula described earlier, but with the addition of the various cross-dimer energy and TM mismatch terms. The resultant multiplex set rating is a function of the rating of each of the component assays and the compatibility of each assay with the other assays of the multiplex set. It is important to realize that with 50 or so assays for each of the 4 sequences, there are more than 6 million multiplex sets possible. Each multiplex set has a total of 108 cross-compatibility terms in its rating. Thanks to fast computers, efficient programming, and innovative algorithms, nearly 1 billion interactions are resolved in a flash. The optimum multiplex set is displayed in the Multiplex Properties tab. A list of alternate multiplex sets is available in decreasing order of their rating by clicking the button. Click the Replace button to replace the current multiplex set with the selected one. Clicking the Multiplex Primer or Multiplex TACMAN Primers button displays all significant cross-homologies among the primers and probes in decreasing order of their stability. Click the Primer All Structures and the TACMAN All Structures button to see a graphical representation of the oligo secondary structures. You can blast search the primer pair, amplicon, or probes of a sequence in a multiplex set against the relevant database to verify their specificity. In addition to all the non-redundant databases available at NCBI, the redundant NR database is also available for verification blast. From the Analyze menu, select Blast Search Primer Pair, Amplicon, or Probe, or right-click on the desired set. The Blast Information tab shows important parameters used for the search. Clicking the link shows you the details. Results can be exported to a .csv file. Go to the File menu and select Export TACMAN Results. You have the option of exporting either the best assay or all the assays. To export multiplex results, select Export Multiplex Set Results from the File menu. You may export either the best multiplex set or all of the design set. Molecular beacon design is a 2-step process. First, design the primer pair, then the beacon. Both are similar to TACMAN primer and probe design. We have provided parameter values based on considerable research and private communications with one of the inventors of the molecular beacon technique. We recommend not changing these values unless you have a specific experimental requirement. Highly accurate hairpin TM values are calculated by connecting to the QuickFold server. You can select up to 5 sequences and check the multiplex option to design a single-tube multiplex reaction. Allele ID checks for cross-dimers among all primers and probes of the sequences, preventing competition. To design fret probes, switch to the fret mode. The program designs 2 fret probes and a compatible primer pair in the same search run. Default parameter values are optimized for fret assays. This mode is similar to the TACMAN assay, except that allele discrimination and multiplexing